So last week, we just had another discussion about a variety of different things here, but last week we talked about while loops, and this week we're going to talk about another repetition structure that will also be just as important, but is a little bit different. Justin, put the squirt gun down, please. Right. Um, we're gonna talk about a different type of loop this week. Last week with while loops are more for loops that you don't necessarily know how many times the loop has to run for. You can set up a condition like whether or not input from the user equals a certain value, and the loop will run until that value is correct. This week we're going to talk about a loop that runs for a specific number of steps. In this case, it is called a for loop. For a certain number of times. Get it?
Oh, so let me guess. This time our task is to do a password but have like 3 attempts or something?
No. This week is not a password assignment. For loops are used in a variety of different ways in programming. One of the very specific ones is with something called arrays. Arrays is coming two sections after this one, 2 chapters. Next week we'll be talking about methods, and then the week after is arrays. But for loops sort of are required before we talk about arrays, simply because of what I'm going to be having you guys do with arrays. But that being said, let's take a quick look at what a for loop looks like. So I'm going to create the structure of a for loop here, and Justin's computer is having kind of a hard time keeping up today for some reason. I'm not quite sure why. He's got a delay of anywhere from like 8 to 12 seconds, even though there's hardly anything running on my network right now. So I'm really not quite sure what's going on there, but Chromecast wouldn't be enough to fill the Technicolor's bandwidth, though. Might be part of it, though. But anyways, so this is the basic structure of a for loop, and I don't know how much of it Justin can see right now, but
I see it.
Oh, he sees it. Okay, that's good. That's good. So let's talk about each piece here. Now, we have our header like we had with a while loop, okay? But there are 3 different pieces that you need in order for your for loop to function. The first thing that you need is an initializer. This basically acts as the index of the loop. How many times have I run through this particular loop? Okay? Now this is treated as any other variable in Java. You have created this variable, it is called I, and you have set it equal to something. Okay?
So could you put an already made variable in there?
Yes. So let's say you took int I and didn't set it to anything. You could then go like this, and this is perfectly legal. This compiles fine. No, it's not. You're probably still catching up.
Oh, there we go. Okay.
This right here is perfectly legal. You can do this. In fact, there is a reason why you would want to do this, and we'll talk about that in a minute here. But let's switch this back to what it was before. The next piece that you need, and of course between each piece you need to put a semicolon, just so you know. That is important. If you don't have that there, this will not work. But the next thing is your condition. What you actually want to base your loop off of, where you want your loop to stop. Okay? So as long as this condition is true, your loop will keep running. Same as with while loops. Okay? In this case, our condition is I is less than 10. Okay? For those of you watching, yes, you just saw my mother pat me on the head. The last piece is the modifier, the increment-decrement value. In this case, all we're doing is setting it up so that each time the loop runs, it will add 1. Okay, if you remember, the plus plus operator means that we add 1. Okay? And we add 1 to whatever value is already stored in that particular variable, I should say. So you could also do this in other ways. If you wanted to count up by 2's, you could say plus equals 2. Okay? If you wanted to decrement by 1 each time, you could do minus minus. If you wanted to subtract by 2 each time, you could say minus equals 2. And there are a multitude of different combinations that you could use. More often than not, you're either going to be adding 1, or somewhat more rarely, you might be subtracting 1. It depends on what you're doing. But more often than not, with a for loop, you're adding 1 each time you run through. So that being said, which one of you two can tell me what numbers will be printed, what range of numbers I should say, will be printed by this loop? Hunter? Would anyone like to change their guess?
No. Yes. 0 to 9.
Okay.
It's going to be less than 10 and start at 0. You know that for sure. Yes. So what's that asking?
What's the range?
0 to 9.
Okay. Are you sticking with it? Still sticking with it. All right. So let's run it.
Oh my goodness. That's right. 10. Wait, was I right?
You were right.
Okay, I can't see it.
Oh, okay.
Very simple.
So if we were to read this loop header as an English sentence, then it says, for I starting from 0, while I is less than 10, add 1 each time. Okay? Does that make sense? You want me to say it again?
No.
Are you sure? Okay. So this is the general idea behind a for loop. There are a multitude of different reasons why you might write this a little bit differently. Like if we wanted to say, do an example where we counted up by 2's, then who can tell me what I plus equals 2 is going to do to change this? What number do we start from? What number do we end on?
0.
Okay.
No, it's going to be 10.
Are you certain?
No. I don't know. Yeah.
Justin,
Well, because...
look at what is written there.
Yeah,
Think about math and look at what is written there.
8 is less than 10, so it's going to be like, okay, so I have another one. But another 1 is actually...
Okay, I see where the confusion is coming from here. So let's look at this a little bit deeper. Okay? Okay. Let's look at this a little bit deeper here. So our for loop gets hit for the first time and is evaluated. Okay? So we start from 0. 0 is less than 10. So the next thing that Java does No. It does what's inside of our loop block.
So it comes off 0.
Yes. That's why 0 appeared first as opposed to 1 in the list. Because Java will evaluate the condition. On the first run, Java does the assignment of the initializer variable, the index, and then it checks to make sure that it's less than 10. Okay? Then the next thing that happens, if that condition is true, is the block of code that is inside our loop gets run. Then at the end, our modifier equation happens. That's when 2 will get added. And then what happens is Java goes back and checks our condition again. Okay? So if we were to write this out in comments, first thing, create index and set it to 0. Second, check condition. 0 is less than 10 equals true. Okay? Third, run loop. Fourth, do modifier. Modifier equation. Okay? Fifth, check condition. 2 less than 10 equals true. Okay? Run loop. And so on and so forth. Okay? Does that make sense? Does that make more sense? So when we get to the condition of, so let's look at, let's put some ellipses here. So we get to the condition where it checks, so check condition, 8 less than 10 equals true. Okay? The next thing that we would do is run the loop. And then the next thing that would happen is do modifier equation. Can't spell today, apparently.
Oh, so before it prints it, it does a modifier.
Yes.
So no matter what, it gets to 10.
So then it will do check condition. 10 is less than 10, which is false. Okay?
So then don't print.
Right.
Okay.
So you start off from 0, but immediately after it creates 0, it doesn't add 2. As long as your condition is true, it does your code block, and then it adds 2. Okay? So it's sort of like an afterthought. So you can think about it as, this is step 1, this is step 2, this is step 3, this is step 4, and then this is 5, 6, 7, 8, and so on and so forth. Okay? Make a little bit more sense this time? Okay. So one thing that I want to touch on really quickly is something called scope. No. Scope is the idea that certain pieces of code are isolated from others, and certain variables in the code are isolated to those locations. A little bit more subtle than that. So, system.out.println I. Is that legal?
I cannot tell. No. Yes, because it's still at 0. Oh, yeah.
I'm waiting for Justin to actually make a concise answer, because he said yes and no at least 6 or 7 different times each.
Yeah, all you gotta do is you gotta print 10. Oh, no.
Are you sure?
Yes. No. 8. Oh my goodness, this is...
So my window broke.
Yeah,
So, errors found in class. Why?
oh, I can't.
Everything's sort of broken right now, but that's okay. Errors found in class.
Yeah.
Why?
Because
It's not an actual word or anything.
well, no, it's saying.
Well, no, I is a variable. But why?
But it's being used in for and not anywhere else.
Very good. So when you say int I equals 0 inside your for loop header, that variable only has scope inside your for loop, inside these brackets. It can only be seen by your program inside those brackets. Okay? Once your program leaves those brackets, that variable is destroyed. Java has no idea that it exists anymore. And your compiler will tell you that. That's why it says errors found in class. And in
like super or something and bring it back.
no, but I will show you how to alleviate that issue here in a minute. But if you actually hover over where there's red squiggles underneath the I, it will say cannot find symbol, variable I. So it will tell you, I have no idea what you're talking about. This doesn't actually exist.
Unless you make it exist.
Correct. So the way to alleviate this is to declare your variable outside of the scope of your for loop, which is something that I showed you guys earlier with the question of, is this legal?
Oh, this.
If you compile this, it compiles fine. Okay? And Justin actually had it right. If we run this,
I like turn my graphics audio.
if we run this, we see 10, even though the loop never prints 10. It's this print line outside of the loop that's printing 10. That goes back to that whole thing where the modifier equation is the last step, and then your condition is re-verified. And because the condition failed, the loop never prints it, but the system.out.println that we put after does. Okay? Does that make sense? Okay. So I just wanted to cover that really quickly. Scope applies to anything that requires brackets in Java. If statements, while loops, for loops, methods, classes, else if, Justin mentioned that a moment ago. It applies to everything. So if you have a variable that you've created and you find that you can't compile because it says it cannot find the symbol, it's very possible that you have a scope issue. So just as an aside, let's say that I create a variable in here called pi. 3.141592653. So what is the scope of I? Where can it be seen? Anywhere inside of what?
Those brackets.
Which brackets? Associated with what?
The curly brackets associated with the 4.
Int I, it has the scope of what?
Oh, wait. Int I. Everything.
No. Int I has the scope of what? Remember, specific to brackets.
The I in the parentheses.
Specific to brackets.
So the 4.
The one's 4.
So I have I highlighted.
Yes.
Okay?
I can see it.
I can be seen both inside the for loop
Yeah,
and outside of it.
that's what
But it's not everywhere because it's specific to brackets.
Oh, okay.
What
So
does it
in the
have?
public void.
Thank you. I has a scope of anything inside public static void main string args after this point right here. This one right here. Okay? Because remember, scope is specific to the brackets that it's contained in. So everything inside those brackets as well also can see that variable. Okay? Scope is sort of like an overarching hierarchy. You know Russian nesting dolls? He's never seen a Russian nesting doll?
Dude, it's like those, you know, the thing
Really?
go inside, like little doll.
Like the little wooden dolls that you unscrew them and you open them up and inside is another little doll and you unscrew them. A Grimwald. A Grimwald.
There you go.
That's a good one for it. Yes. Same sort of idea. It is a nested structure. Anything inside one layer of the doll, it has the same scope as everything below in the rest of the doll. You can think about it that way. It occupies the same space. Okay? But nothing above the initial space. Anyways, I'm not even sure what I just saw. So then, what is the scope of pi?
Just inside the 4. Like that.
Okay, Hunter?
I'm actually gonna have to read on that. That's where it's
And that's correct. It is only available to be used inside the for. If we said system.out.println pi outside of the for loop,
it would become false.
it would give us an error. We wouldn't be able to compile. Okay? Makes sense?
Yeah, that must be confusing though, like when you have like pi in 13 different places.
What?
Because like you want to use pi, and you got it like up here, and you got it down
Oh,
there.
like putting it in between different things.
Yeah.
I mean, it would be no more confusing than doing this. Oops. It would be no more confusing than doing that. Like this, it compiles. It'll run too. Oh, hello, Chrome. Count up by 2s, print 10, and then start counting from 10 and go all the way back down. Well, you'll get there, I promise. I'm surprised Hunter's... Well, it might be that computer. You're not having any major delays? You can see what I'm... Yeah, that's probably just that computer. We'll have to find a way to boot from...
But I thought it was only as good as the user.
No, what?
Oh, okay. No more taking shots. All right. So we're gonna stop here. We've talked about scope and we talked about for loops a little bit. We got a little bit more to do this week. We're gonna take a quick breather, let my mouth rest a little bit from all this talking, and yeah, that might help. But we're gonna stop for a minute. We don't have too much more to do, but all right.